Hello, sixth graders, and welcome to day 2 of sequences. So yesterday we worked on the lab where we were graphing and writing rules. Today we're starting our last packet of the year. I know, sad. And we will be working on sequences again. We're going to complete page 2 notes today with a video lesson, and then page 3 is your independent practice. We'll be correcting that practice on next Tuesday. You can see that our test is coming up on June 2nd, so a week from Tuesday, and this is how the rest of the unit will run. Alright, let's turn to page 2, and we're going to start with the vocabulary section. Alright, our first term is sequence. Sequence is an ordered list of numbers. And we can see over at the right there's an example of a sequence. So we have n, the position in the sequence, followed by y, the value of the term. In our lab yesterday, x was the position in the sequence. It was our figure number, and then y was the number of tiles. So this is going to be similar. We were using sequences yesterday as well. Each number in a sequence is called a term. So in our example for sequence, are the 2 in the first position, that would be the first term in the sequence, and the 4 in the second position would be the second term in the sequence. Alright, for this section it says identify functions in sequences. Write a function that describes each sequence. You're going to notice some similarities to part of our sequence lab day yesterday. We're going to be given a sequence. We don't see a pattern like we did yesterday, but we are given a sequence at the top of the box and then asked to use a function table and figure out what the pattern is. So the big piece that's different is we're not seeing it the way we saw it when we looked at those patterns made with boxes. So let's go ahead and fill in these terms of the sequence into the function table. So the first term is the first number showing up, so that's a 3. The second term I'm given is a 6, the third term a 9, and the fourth term is a 12. Now, just like yesterday, we're going to take those terms and try to figure out the rule. So if you remember yesterday, I said let's start with checking, is it an add rule, is it a multiply rule, or is it a combination of multiply add? So those are the 3 things we want to check. And first we want to rule out add multiply. So if this was an add rule, to get from a 1 to a 3, I would be adding 2. If this is a multiply rule, to get from a 1 to a 3, I would multiply by 3. So I'm going to check both of those. Well, if it's add 2, does that work with a 2? So in the second term, is 2 plus 2 6? Is 3 plus 2 9? No. So it is not plus 2. Is it times 3? Well, 1 times 3 is 3, 2 times 3 is 6. So yes, we know that our rule is multiply by 3. So we're going to put that 3 times parentheses. It's 3n, but we're going to be substituting in our n values. So I'm putting parentheses where we're going to be substituting in our n values. And remember, when we mush that parentheses up to the coefficient, it's multiply. So in the first one, n is 1, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 in the third term is 9, in our fourth term, 3 times 4 is 12. So now we want to write a function. The function is the equation that sums up the rule that we noticed, the pattern we noticed. Functions are going to start with our y equals 3, and what we were multiplying by 3 was our n value. So y equals 3n, just like yesterday we were using x and y. Example 2 is similar. Again, we're given a function, so we're going to substitute in these values for our y terms. So -4 is the first term, -8 is the second term, third term is -12, and the fourth term is -16. So as we learned on Tuesday, when we're multiplying with those negatives or adding negatives, we're gonna have to think in that way. And you're welcome to use a calculator. On a calculator, most scientific calculators have a little negative button. It looks like parentheses with a negative in it. So you would use that, not the minus sign, to enter a negative. All right, so again, I want to look at what's happening to get from my n value to the y value. So I'm going from 1 to -4. Well, -4 is 5 less than 1. So it's either subtract 5 or add -5. Or if it's multiply, that would be 1 times -4. I'm going to put that -4 in parentheses. And I'm going to try both of those. Well, if it's a -5 rule, 1 minus 5 would give me a -4. If I go down to the next line, 2 minus 5 is not -8. 2 minus 5 would be -3. So I know that it's not -5. Times -4. Well, 2 times -4 would be 2 times 4, and the signs are different, so it's negative. 1 times -4 would be 1 times 4. Signs are different. +1, -4. So that's a -4. I think we found our pattern. So our rule, what we notice happening is we're doing -4 times our n value. So I'm just going to write that in with those parentheses on each of these. And then I'm going to substitute in my n values. So first term, second term, third term, fourth term. And I'm going to at a glance make sure it's working for all of them. It is. And so now I can write my function or derive my function. Y equals -4 of n, -4 times n. Now this part of the lesson, for example 2, is maybe going to remind you of that thing we did yesterday where we looked at the 100th term in the sequence. So here we're going to fill out the table and use it to extend our sequence to a different situation. So it says Charlie Brown keeps a list showing his cumulative earnings for raking lawns. He recorded $12.50 for the first time he raked a lawn, $25 for the second time, $37.50 the third time, and $50 the fourth time. Write a function that describes this sequence and then use the function to predict his earnings after 8 lawns. So I'm going to pause. I want you to pause and go ahead and fill in the terms in that sequence, how much the first lawn, the second lawn, etc. All right, so now that we've done that, we can look for our rule. So we're going from 1 to 1250, so it's either plus 1150 or times 1250, or a combination. Well, it's not plus 1150 because 2 plus 1150 is 1350, not 25. Times 1250. Well, 1 times 1250 is 1250. 2 1250s is 25. 3 1250s, well, that is 3750. So our rule is multiply our n value by 1250. So 1250 per lawn means we're going to multiply by 1250 each time. So in Notability, you can just copy and paste this part all the way down, and then we'll fill in our ends. All right, so I've done that. You can pause if you need to give yourself time to fill those in. And then we want to answer after what his earnings would be after raking 8 lawns. Well, I know based on my table and my thinking about it that my rule would be y equals 1250 n. And they're asking me what the earnings, which is y, what the earnings would be after 8 lawns. Well, if my term for n is an 8, I want the 8th term in this function. So I'm going to need to use my calculator or write it out and do 1250 times 8. And that's 100. So his earnings would be $100 after 8 lawns. Not bad. Our final example today says Sally keeps a list showing her cumulative earnings for walking Snoopy. She recorded $1.25 the first time she walked him, $2.50 the second, and when it goes on, $3.75.5. Write a function that describes the sequence, then use the function to predict her earnings after 9 walks. So again, let's pause and fill in the function table. Let's see if yours matches mine. All right, so I've gotten this far. I noticed that each time she walks Snoopy, she gets $1.25. So this is going to be a multiplication pattern. So each time it's times $1.25. So first term is $1.25 times 1, second is times 2, third times 3, fourth times 4. So our overall rule is y equals $1.25 times n. And n is how many times she's walked the dog. So in this case, we're solving for Snoopy's 9th walk. So we're going to fill in a 9 at this point, and then pause, use your calculator, label your answer, and make sure it matches mine. All right, so when we multiply our $1.25 times 9, we get $11.25. Which means that Sally would have earned $11.25 after 9 walks. Your independent practice is found today on page 3 of the packet, and this top part is an answer bank. So what we're doing is matching the function with the rule. So we're doing the same thing. You're not applying it to an extra thing in this one. So I want you to fill in the function table and then use those rules as a bank if you're getting stuck. You don't have to use the bank if you can figure out the function without it, but do kind of look up there, make sure that it's showing up. I'll do the first one with you. So first I'm going to enlarge that table and fill it in. Okay, so I filled in my y values, first term, second, third, and fourth term, and I'm going from 1 to -3, 2 to -2, 3 to -1. So if it is an add rule, to get from a 1 to a -3, it would be adding a -4, or we can think of that as -4. Or if it's a multiply rule, we'd be multiplying by -3. Well, 2 minus 4 is -2. 4 less than 3 is -1. So I know my rule is y equals n minus 4. Y equals n minus 4. And here I'm going to write and fill those in. 1, 2, 3, 4. Now, these aren't going to be used more than once, so you can cross them off once you've used it. You might have noticed the numbering is beginning with number 5. That's because we did 4 examples in the notes, which count as the first 4, and then we'll finish here. So you're going to do those 6 function tables, and then here, which function describes that sequence. You can copy one of those function tables from above and paste it down in here if that helps you. And then circle the ordered pairs that are solutions. So try substituting in these numbers for x and y, and any that work, where y does equal 3 times the x number minus 4, you're going to circle. So it doesn't say circle the ordered pair that works, it said pairs. So there may be more than one correct answer. All right, thanks a lot. Have a great rest of your Friday, and I'll be available to help if you get stuck. All right, bye-bye. I will see you Tuesday. Happy Memorial Day weekend.